Hi everyone, I'm Dr. Morley, and along with Mr. Williamson, I teach the A-level physics course. Before we get into too much detail about what's actually in the course, have you ever wondered why the universe behaves the way it does? Or how ultrasound can create a picture, or how fast you'd have to be going to be able to fool a speed camera? Are you the kind of person who's interested in getting a qualification that leads to lots of different options at university and beyond? Are you curious about how the universe works? Are you interested in problem solving? If those are the kind of questions you're asking and that's the kind of person that you want to be, then maybe A-level physics is the course for you. Because in physics, we're all about asking the big questions about how and why the universe behaves the way it does, and about trying to develop models that allow us to understand it and make predictions about what might happen in the future. We're going to talk in the next few slides a little bit about what's actually in the A-level course and the careers and places that it can lead you. And we look forward to teaching you on the course in September.
Hi there, I'm Mr. Williamson, and I teach the A-level physics course alongside Dr. Morley. For the next few minutes, I'm going to take you through what you would actually expect to be learning during A-level physics, what the content is, and what it is that we cover. We're going to start with Module 3. That's because Module 1 and 2 are small units of skills which are used throughout the A-level physics course, practical skills and things like that. I'm going to talk more about that later. Module 3 is the first of two main units of content that is taught in Year 12, and it's all about mechanics. Mechanics of motion, objects interacting with forces, density, pressure of different materials, and mechanical properties of matter. We take all of this and it really sets us up with the skills and with the knowledge that we need to analyze situations and to apply this when we look at everything from small scale objects such as electrons interacting with atoms all the way through to huge scale objects of stars or galaxies. Moving on from the mechanics of Unit 3, the second module of content that you will cover in Year 12 is this module on electrons, waves and photons. So this builds on the content on electrical circuits you've done back in GCSE and expands that further with a little bit more detail about what's going on smaller scales with electrons inside wires and how that behaves into electric circuits that we observe. We also do a lot more about waves, including some really interesting effects about superposition interference that produce some of the most spectacular images and optical illusions and things like that that we see and sometimes experience. We also have an entirely new branch of physics called quantum physics, which you haven't really met before at GCSE. This one is where all the weird and wacky and extremely interesting ideas, quantum tunneling and things like that exist, which you may have heard of if you've done a bit of reading or listening to videos and things about physics, and it's extremely. Moving on to the second year content, Module 5 contains thermal physics and gases, which is all about objects and how they behave at different temperatures, particularly very cold temperatures down near absolute zero, all the way up to really hot temperatures. You have millions of degrees inside a star, for example. After that, we continue on to circular motion, dealing with any form of object that moves in a circle, from spinning hard drives to orbiting planets, and then going further to look at interactions between objects due to gravity, particularly on larger scales, again thinking of things like planets orbiting stars, which leads us really nicely on to looking at the universe, the astrophysics topic, my personal favourite part of the course, dealing with everything from things within our own solar system all the way out to a whole universe scale. How did the universe begin? How did it end? How will it end? And everything in between. So Module 6 is the final unit of content taught in Year 13, and we begin by looking at electric fields and magnetic fields, different ways objects can interact with each other if they're charged or if they're magnetized, and some of the more exotic effects that can happen with superconducting magnets and really strong magnetic fields, and when particles are traveling in these magnetic or electric fields, what happens to them. We also move on to look at particles in more detail, things like protons. What are they made out of? What does the Large Hadron Collider actually collide? And what do they searching for? All of this brings us to fundamental particles and nuclear physics, and is really one of the frontiers of physics at the moment, under active research, and is an extremely interesting area to be learning about because discoveries are being made all the time. The final bit of this unit is an application, medical imaging. So how are some of these concepts used to take images like the one here on this slide, using radiation, using particles in order to collect data from inside of the human body. Running alongside the main A-level course, we also have the practical endorsement. This is an extra bolt-on to the grade that you get at the end of the A-level. So you also have a practical endorsement, which basically says that you have been trained and assessed in practical scientific skills. So alongside your grade, you will have this practical endorsement that provides added value to yourself when talking to employers and universities, because it shows that you are competent in a large range of scientific investigation techniques. So this is run alongside the main content, linking with the content of the A-level, and also providing additional help and support with the practical questions we get in the exams at the end. So we will carry out 12 different investigations over the course of the 2 years, on top of the normal practicals that we would do in class. These will count towards this practical endorsement and gain a large range of practical skills alongside the main knowledge from the A-level.
So, the great thing about physics is it opens up so many doors at university and at careers beyond. I mean, there are the obvious things. With a degree in physics, you could go on to become a physicist, a researcher, looking at astrophysics, where the universe came from and where it's going, or particle physics, what's matter itself made of, or in related subjects, in climate science, in geophysics, in a whole host of different related engineering disciplines. But beyond that, there are so many other things that a degree in physics can bring you, because the knowledge, the skills and the understanding that you develop as a physicist are valued in a whole host of different industries. In high-tech industries like nanotechnology or space science or energy or electronics and manufacturing, those skills are valued. Or in banking, in finance, where your ability to use mathematical models to understand complex situations and make predictions are really important. Or in law, bringing your understanding of science and technology to patent law. In education, in teaching, in healthcare and allied disciplines, all of those different things that you learn as a physicist are really valued. And then there are things that are even less directly related to physics, as a science journalist working in the media, or in the entertainment industry as a graphic designer in the computer games industry, or in visual effects for films. All of these different things are doors that become open to you as a physicist. If after A-levels you go on to take a degree, your earnings are around 23% higher than someone who's just got A-levels. If you do physics, your earnings tend to be about 30% higher, which is twice as much as someone who's done psychology as a degree, or biological sciences, or history as a degree. Physics is where the money is. The link here on the slide would take you to the Institute of Physics careers page. They've got a whole host of information about different careers that physics can take you to, and they've got loads of information, case studies and profiles from different people who've done physics degrees and where their degree has taken them. You might find that information useful when you're making your decision, but feel free to get in touch with either of us if you've got any questions at all.